Students, welcome back to the channel. Today I am here with another video on the same chapter, that is some basic concepts of chemistry. Already we have completed one video. The link of that video is provided in the description. Please go and check it out. And today we are in the second video, and in this video we are going to discuss the properties of matter and their measurement. Okay, it is the third topic of the chapter, properties of matter and their measurement. Under this topic we are going to learn about meaning of physical and chemical properties, meaning of physical and chemical properties, and their measurement. Every matter has two types of properties, physical properties and chemical properties. We are going to discuss in detail the physical and chemical properties and how they can be measured. Okay, what are the various systems used for their measurement? In that various systems, SI system of measurement is the most important one, about which we will learn in detail in today's video. Then we are going to discuss about some of the terms such as mass and weight. We will discuss about volume, density, and temperature in detail. So this is the brief summary of today's class. We are going to learn the difference between physical and chemical properties, what is meant by physical and chemical properties, and how are they measured. And in those systems of measurement, we are going to learn about SI system of measurement in detail. And then we will discuss some of the terms such as mass and weight, volume, density, and temperature. So, if you find the content of the video useful, please do like, share and subscribe, and comment your views on the video, and if you have any doubts also you can comment it below. Coming to the first topic of today's video, that is physical and chemical properties. So children, every substance in this nature has unique or characteristic properties. That means if we know the unique or characteristic properties of any particular substance, we can tell what it is, what is the nature of that substance. Many details of that substance can be told. Now these properties are mainly of two types, that is physical and chemical. Properties of any substance in this whole universe is mainly of two types, physical and chemical. Coming to the physical properties, what is meant by physical property? The properties which can be measured or observed. The properties which can be measured or observed without changing the identity of the substance. Okay, what is meant by physical property? The properties which can be measured or observed without changing the identity of the substance. Identity or composition of the substance is also not changed here. But if you have to find out the chemical properties of any substance, you have to carry out a chemical change. A chemical change has to occur in the substance in order to find out its chemical properties. Whereas you can tell the physical properties without any changing the substance. Okay. Examples of physical properties are color, odor. Odor means smell. Melting point, boiling point, density, etc. Examples of some chemical changes are composition. That means if you have to tell the composition of any particular substance, first you have to carry out a chemical reaction for that substance. You have to bring a chemical change in that substance. Then only you will be able to tell the chemical properties of that particular substance. So examples of chemical properties are composition, combustibility, reactivity with acids and bases, etc. Okay children, so did you get a clear picture of what is meant by physical property and chemical property? What is meant by physical properties? The properties which can be measured or observed without changing the identity or composition of the substance. Whereas if you have to find a chemical property of the substance, you have to bring a chemical change in that substance. Examples of physical properties are color, odor, melting point, boiling point, density, etc. Examples of a chemical change are composition, combustibility, reactivity with acids and bases, etc. Now let us learn about measurement of physical properties. Now let us see how the physical properties of various substances can be measured. Physical properties of any substance requires a quantitative measurement. Okay, measurement of physical properties should be quantitative in nature. What is meant by quantitative measurement? Means the measurement which has a number and a unit. Okay, what is meant by quantitative measurement? A measurement which has a number and a unit. For example, you have to tell the length of the room. The length of the room is 6 meters. Here 6 meters is a quantitative measurement because it has a number that is 6 and a unit that is meter. So, quantitative measurement means the measurement which has a number and a unit. For this measurement, various systems were proposed. The most two common systems of measurement are English system and metric system. Among English system and metric system is considered to be the most convenient one as it is based on the decimals. Since it is based on the decimals, the accuracy of measurement will be more, and this system of measurement originated in France. But still the scientists found that there is still a need for the standard system of measurement, and hence in 1960 they proposed the SI system of measurement. Now what is the SI system of measurement? Let us see. This international system of units was proposed in 11th General Conference on Weights and Measures. It is also known as CGPM. Okay. So, this international system of units, which is also abbreviated as SI, it was proposed in the 11th General Conference on Weights and Measures. This SI system of unit has 7 base units. How many base units it has? 7 base units belonging to the 7 fundamental quantities. These are the 7 base units, and the remaining units such as speed, volume, density, all these can be derived if you know these 7 base units. Now let us see what are these 7 base units. Students, these are the 7 base physical quantities. What are those 7 base physical quantities? Length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. That means if you know the units of these 7 base physical quantities, the units of all the remaining physical quantities you can derive it. Now let us see the symbols for the 7 base physical quantities. The symbol for length is L. Its SI unit is meter and the symbol for meter is M. Okay, like that you have to remember. Next, symbol of mass is small m and its SI unit is kilogram. Symbol for time is small t and its SI unit is second. Symbol for electric current is capital I and its SI unit is ampere. Symbol for thermodynamic temperature is capital T and its SI unit is Kelvin. Symbol for amount of a substance is small n and its SI unit is mole. Symbol of luminous intensity is IV and its SI unit is candela. Now you have to remember the symbols for these SI units. Symbol for meter is small m. Symbol for kilogram is kg. Symbol for second is S. Symbol for ampere is capital A. Symbol for Kelvin is K. Mole is MOL. Candela is CD. So you have to remember these 7 base physical quantities. There is no other shortcut for this. Just you have to read them. Okay. Now, the SI system of units use prefixes which indicates the multiples or submultiples of a unit. Now let us see what are those prefixes. These are the prefixes which are used in the SI system of unit. These also you have to remember. There is no other option for it. Multiple, prefix and symbol. 10 to the power minus 24 is yocto. 10 to the power minus 21 is zepto. 10 to the power minus 18 is atto. 10 to the power minus 15 is femto. 10 to the power minus 12 is pico. 10 to the power minus 9 is nano. 10 to the power minus 6 is micro. 10 to the power minus 3 is milli. 10 to the power minus 2 is centi. 10 to the power minus 1 is deci. 10 is deca. 10 to the power 2 is hecto. 10 to the power 3 is kilo. 10 to the power 6 is mega. 10 to the power 9 is giga. 10 to the power 12 is tera. 10 to the power 15 is penta. 10 to the power 18 is exa. 10 to the power 21 is zeta. And 10 to the power 24 is iota. Okay. Daily if you make a table of this and fix it in the room, and every day if you look into it once, easily you will be able to remember it. There is no much big issue. Okay. Into the next topic, that is mass and weight. Remember students, mass and weight are very much similar terms. You have to be very careful while using these terms. So for an easier understanding, let us study about mass and weight in the form of a table. If you know the difference, then you will be able to remember it easily. Now what is meant by mass? Mass is the amount of matter present. Mass is amount of matter present in it. Whereas weight is the force exerted by gravity on an object. Force exerted by gravity on an object. Okay, this is the main difference between mass and weight. What is mass? Mass is the amount of matter present in it, whereas weight is the force exerted by gravity on an object. Remember students, mass of any substance is constant. Mass of any substance is constant, whereas weight of a substance vary from place to place. Why weight of a substance varies from place to place? Because the force is different for different places. Because weight is dependent on the force, it varies from place to place. So what is the weight of a person on the earth will be different from the weight of the same person on the moon. Okay, now this weight can be determined accurately by using an analytical balance. How is it determined? It is determined by using an analytical balance. An analytical balance appears like this. So, to get a short idea about the analytical balance, you can look into the picture. It is present inside a box in which even air is also not present. That means it is measured in vacuum state. Okay. This analytical balance consists of a rider carrier. It has a rider carrier knob. It has a beam, pan. On one side you will put the weight, and on another side you will put the substance whose weight is to be determined. Then there are leveling screws to make the balance stand. There is a pan release and there is a beam. Detailed usage of it you will understand in your practical examination. In your practical classes, your teacher will explain about this analytical balance very clearly. Okay. Now coming to the SI unit, its SI unit is kilogram. Its SI unit is kilogram, and its fractional unit or smaller unit is grams. In the laboratory, mainly we depend on grams, not on kilograms. Very small quantities are measured in the laboratory. And here one important conversion you have to remember. 1 kilogram is equal to 1000 grams. Okay, 1 kilogram is equal to 1000 grams. So, did you get a brief idea about mass and weight? What is mass? Mass is the amount of matter present in the substance. What is weight? Weight is the force exerted by gravity on that object. Mass is constant. Weight varies from place to place. Why weight varies from place to place? Because force is different from one place to another. Gravity is different from one place to another. So obviously the weight will also vary. And these are measured by using an analytical balance. SI unit is kilogram. Its fractional unit is gram. And conversion which you have to remember is 1 kilogram is equal to 1000 grams. Okay. Now let's go to the next topic. Next topic that we are going to learn about is volume. Now what is volume? Volume is the amount of space occupied by an object. What is volume? Volume is the amount of space occupied by an object. Its SI unit is length cube. SI unit of length is meter cube. Okay, this is the SI unit of volume. And in laboratory I told we measure smaller quantities, no? So its fractional unit or smaller unit will be centimeter cube or decimeter cube. Okay, the common unit of measurement of volume, can you tell, which we use in our day-to-day life? It is liter. It is liter, but this is not an SI unit, remember students. Next, the conversions which you have to remember is 1 liter is equal to 1000 ml. Okay, 1000 centimeter cube is equal to 1 decimeter cube. Okay, now there are various instruments by using which you can measure the volume. What are those instruments? Let us see. So students, these are the various instruments which are used to measure the volume of any liquid. The first one is burette, second one pipette, third one graduated cylinder, and fourth one is volumetric flask. Now burette can measure up to 50 ml. It has graduations up to 50 ml. So it starts from 0 at the top to 50 at the bottom. Next, pipettes. Pipettes will be of different measurements. There will be 10 ml pipettes, 25 ml pipette, and so on. Here in the picture we have 25 ml pipette. Next comes graduated cylinder. With this graduated cylinder, it is very easy to measure the volume of the liquid. Directly you can pour the liquid from the top. Okay, so if it comes till here, it is 10 ml, 30 ml, 50 ml and so on. The next one is volumetric flask. Volumetric flask will also be of different measurements. There will be 100 ml volumetric flask, 250 ml volumetric flask, 500 ml volumetric flask. Here we have 1 liter volumetric flask. There will be a marking at some point over this tube. That means you have to fill the water up to that mark only. Then only you will get the correct volume of water. So these are the different instruments which are used to measure the volume of any liquid. Okay. Now coming to the next topic, that is density. What is meant by density? Density is the amount of mass per unit volume. Okay, what is meant by density? Density is the amount of mass per unit volume. It is relating the two properties, mass and volume, which we have discussed. So you can write the formula as density is equal to mass by volume. Okay, what is density? Density is the mass per unit volume. Its formula is density is equal to mass by volume. Now see students, you need not remember the SI unit of density. If you remember this formula, you can derive its SI unit. What is the SI unit of density? SI unit of density will be SI unit of mass by SI unit of volume. Okay, based on the formula we can write SI unit of density will be SI unit of mass by SI unit of volume. Okay. Now what is SI unit of mass? Kilogram. What is SI unit of volume? Meter cube. When this 3 goes to the top, it becomes -3. So kilogram per meter cube. Remember, in laboratories we use the smaller units, no? So smaller unit will be, what is the smaller unit of kilogram? Grams. What is the smaller unit of meter? Centimeter. So gram per centimeter cube. Here you have to remember one important relation. Density of any substance is directly proportional to packing of particles. Packing of particles means what? If the density is more, the particles are closely packed. That means it will be a solid. If the density is less, it means the particles are loosely packed. So density is directly proportional to packing of particles. Directly proportional means if one quantity increases, the other one will also increase. Okay, so this is about density. Very easy, isn't it? What is density? Density is the amount of mass per unit volume. So you can write the formula of density as density is equal to mass by volume. Based on this formula, you can derive the SI unit of density. What will be the SI unit of density? SI unit of density will be SI unit of mass by SI unit of volume. SI unit of mass is kilogram. SI unit of volume is meter cube. So kilogram per meter cube. Since in laboratories we use smaller units, smaller unit of kilogram is gram and meter is centimeter. So smaller unit will be gram per centimeter cube. Here you have to remember one important relation. Density is directly proportional to packing of particles. Means what? If the density is more, the particles are closely packed. If the density is less, the particles are loosely packed. Okay, now let us learn about temperature. Now coming to the last topic of today's class, that is temperature. We usually have 3 common scales to measure temperature. What are those scales? First one is degree Celsius. Degree Celsius. Second one is degree Fahrenheit. Degree Fahrenheit. And third one is Kelvin. So these three scales of measurement are usually used while measuring the temperature. What are those three scales of measurement? First one is degree Celsius, second one is degree Fahrenheit, and third one is Kelvin. Let us look into the relationship between these three. So this is the Kelvin scale thermometer, Celsius scale thermometer, and Fahrenheit scale thermometer. In Kelvin scale, the highest temperature that can be recorded is 373 Kelvin and the least temperature is 273.15 Kelvin. In Celsius scale, the highest temperature is the boiling point of water, that is 100 degrees Celsius, and the least temperature is 0 degrees Celsius. In Fahrenheit scale, the highest temperature is 212 degrees Fahrenheit and the least one is 32 degrees Fahrenheit. Okay. So this 0 degrees Celsius or 32 degrees Fahrenheit is the freezing point of water. Is the freezing point of water. 100 degrees Celsius or 212 degrees Fahrenheit is the boiling point of water. In between we have 37 degrees Celsius, or in Fahrenheit scale 98.6 degrees Fahrenheit, which is the human body temperature. Remember students, more than 98.6 is considered to be a fever. Okay, next 25 degrees Celsius, or in Fahrenheit scale 77 degrees Celsius is considered as the room temperature. Okay, now let us see the relationship between these three scales of temperature. First one, let us see the relationship between Fahrenheit scale and Celsius scale. Relationship between Fahrenheit scale and Celsius scale. Degree Fahrenheit is equal to 9/5 degree Celsius plus 32. What is the relationship between Fahrenheit scale and Celsius scale? Degree Fahrenheit is equal to 9/5 degree Celsius plus 32. Next, relationship between Kelvin scale and Celsius scale. Kelvin is equal to degree Celsius plus 273.15. Kelvin scale is equal to degree Celsius plus 273.15. So students, you have to remember these two formulas. In the first formula, it gives us the relationship between Fahrenheit scale and Celsius scale. They might ask you problems also. They will give either the Fahrenheit temperature or the degree Celsius temperature, and they will ask you to find out the other temperature. Similarly, in this also, they will give you either the Kelvin scale temperature or the degree Celsius temperature. The one temperature they will give and they will ask you to find the other one. So just by substituting, you can find out the other temperature. So did you understand? Relationship between Fahrenheit and Celsius will be degree Fahrenheit is equal to 9/5 degrees Celsius plus 32. Relationship between Kelvin and Celsius will be Kelvin is equal to degree Celsius plus 273.15. Okay, with this we complete today's video. Please do comment if you have any doubts. If you have understood everything and do not have any doubts, please do comment the same in the comment section. Please tell me your opinion on the video and help us to improve. Let's grow together. Thank you.